You've got an expression there, 5 linear terms to multiply out, and when you multiply them out, you'll get a polynomial of degree 5, because there x is 5 times in those terms, and you'll get a whole lot of other stuff. Now, that's a good deal of rather tedious effort to multiply it out. The question is, however, when you've multiplied it out, determine the value of the sum of those 5 coefficients. So you take a deep breath and you multiply out a quadratic and another quadratic and linear term, and eventually you'll get this string of terms, and then you add up all the coefficients and you get your answer. But really, with a little bit of insight, it's a lot easier. The solution is to denote by p of x that polynomial, and it's then multiplied out into the sum of those 6 terms. But then the sum of the coefficients is exactly this expression here with 1 put throughout. So what is p of 1? We'll go back to the actual equation, put x equals 1, and there's a factor there which makes the answer 0. And it's obvious, without doing all the work in between. So those are 2 little problems that I think will test insight and understanding, and not just climbing in and doing that tedious manipulation. Well, today I want to talk about maths in the media. I built this event originally as examples of mathematical errors or howlers in the press, but then thought I should expand this to include the internet and other things like that, and could have expanded it even more, but it would have taken more than one lecture to go into mathematics in television shows and movies. But that's maybe a subject for another summer school course. So I've been collecting these mathematical howlers over the years. Some of them are really quite funny when you think about them for a little, but that's my point. That when you see something numerical in the press, just think about it a bit, because it might be worth thinking about. And after all, we are bombarded by numbers, the radio and television. So don't just swallow them, chew them over a little. They may need to be digested in that way, sometimes just spat out. So let's start with something that was on the internet. The International Rugby Board publishes ratings of sides, and this is what they wrote. Argentina and Samoa both had a rating of 78.71, whatever that means. But when expanded to 15 decimal places, they give those 2 15-digit decimal places numbers. Now, what on earth is going on there? This is what I would call spurious accuracy. There's no point in putting down 15 digits, unless, of course, you've been playing with your calculator and you punched the equal sign and those things came up and you thought that I'd better use them all. So there's no point in, when those 2 numbers differ on the 3rd decimal place, you've just got to look at a few decimal places. All the rest is irrelevant. And the numbers that are input into your calculations were probably just short numbers, so I don't know how you could get 15-digit numbers coming out of that. Garbage in, garbage out is the issue. Well, spurious accuracy is something that you see in the papers. Here's something about a satellite orbiting the sun almost 1,609,344 kilometers from Earth. I love that almost. Now that satellite is moving, so you can't set its distance precisely to 1 kilometer when something is going around the sun at goodness knows how many thousand kilometers per hour. So what has happened here? Well, there was a press release that somebody picked up from overseas, maybe from Britain or America, that this Planck satellite is orbiting the sun and it's now about 1 million miles from the Earth. And the reporter thought, oh, I don't think my readers are going to understand this mile idea. What's the connection? So they get out the calculator and they multiply, and they find that a mile is 1,609,344 1.609344 kilometers from Earth. So 1 million miles would be that in kilometers, and so they put that thing down, leaving the almost there, which is, of course, totally irrelevant. There was a report that some years back, Elvis purchased the Graceland property in 1957. Of course, this is Elvis Presley. Graceland was his property. He bought it for a song, nice pun, about 731,237 rands. Again, spurious accuracy. Now, of course, Elvis didn't buy that property for rands. He bought it for dollars. So the question was, what did he pay for it? Well, that's easily found out. You can just go to look up Elvis on Wikipedia or something, and you find the reference there. And in the dollar price of Graceland in 1957 was $102,000 and $500. So that was the dollar price. So how did that price in rands come about? And again, about. When you've rounded your rands off at the last digit, you mean you're trying to get it correct within a few cents. Well, what happened? Well, what was the price then in rands? Rands did not exist in 1957. In sterling, the price was £36,600, and you can look up exchange rates going back 50 years. For every month of the year, you can find the relevant exchange rate. So that was the exchange rate. Well, South Africa only brought in rands in 1961, when the pound that we had been using became exactly 2 rands. So Graceland was therefore sold in rand terms, if you don't worry too much about that gap from 57 to 61, for 73,200 rands. The original report said it was 730-something thousand rands, so the reporter was out by a factor of 10. But what had that reporter done? The reporter had taken that dollar price and then thought, oh, they won't understand dollars, our readers, so let's convert that to rand. So we look up the exchange rate at that time, when it was about 7 rands to the dollar. This is in 2010. And that's how they came up with that number. Now, calculating an exchange rate on a dollar for an event that happened 50 years back is really a bit ridiculous. Here's something which needs to be read through carefully to find out what I'm trying to say about this example of numbers in the press. And it's really related to metrication. So up to 14.5% of the alcohol we drink is illicit, and that cost 6.4 billion rands in lost revenue, and the number of licensed and informal unlicensed outlets is given. Now, the interesting thing about this is that when we metricated, we decimalized our currency in 1961. When we metricated, which was 10 years later, it was a matter of converting lengths and volumes and all that to the metric system. And at that stage, it was decided, and I'll get back to the background, it was decided that we would move from the point to the decimal. But this has only happened sporadically, even though this is 50 years back. We still find the point widely used, and the comma that we were supposed to be using is used certainly in schools, but banks, Pick and Pay, newspapers still haven't really systematized their use. As you see in this report here, they use of 14.5% and then 6.4 billion rands. So they haven't decided what they are trying to do. Also, the use of the comma in the French metric system is for a decimal separator. You don't use it to separate triplets of digits. You're just supposed to leave a gap. And this is sometimes done, but sometimes not. So here you've got a nice mix-up of the use of the comma and the point. Now, the metrication process was very complicated, and the point and the comma issue was quite peripheral. And I have my own little pet theory about what was happening back in 1971. There was a very enthusiastic conversion to the French system. And I think the government of the day was very pro-France. Because after all, when you think about it, we were buying Daphne-class submarines and Mirage fighters. So we had big tradings with France. So therefore, let us use the French comma as opposed to the hated English point, thinking in terms of the Bund and the government of that day. So this is my theory about the comma. If we said that the ANC Ministry of Education, that the comma is an apartheid structure, we might get rid of it, but who knows. The fact is that around the world, to my surprise, the point is used in about half the countries and the comma in about the other half. It's not surprising that the point is still used in Britain, the United States, and Canada, and in former British colonies, say in Africa. It's not surprising that the comma is used all over Europe, including Russia and its former Soviet republics. And in Francophone Africa, the comma is used. And in South America, with the Spanish influence, that the comma is used. But in Asia, in China, Japan, Philippines, Singapore, all the major countries, the point is used. So it's about 50-50 throughout the world. And I don't think it's a problem. We can live with both, just as you should be able to live with miles and kilometers in your general conversation. Here's something, from the New Scientist pickup. New Street Station has low energy lighting and control systems that can save up to 50% less energy than the previous lighting system. So it takes you a little time to sort of comprehend what is being said there. Up to 50% less. Well, I think if they changed the save to use, that might have been okay. But up to 50% less is potentially very confusing. But that reminded me that the advertisements you get with numbers in them in the press often are from as little as 99 rands. In other words, nothing is cheaper than 99 rands. Or up to 50% discount on all sale items. Well, if there's no discount on that particular sale item, that's okay, because they say up to. So anything less than that. It's like your dandruff remedy being up to 100% effective. If it's not effective at all, that's fine. The advertising code is not being breached. And of course, killing 99% of household germs, it depends what you mean by household germs anyway. So it's not just numbers that confuse journalists. Units can be even more challenging. Here's a report. Zimbabwe's gold production had slumped 32% to 7.5 million tons last year. 7.5 million tons of gold? So what was the problem in Zimbabwe? It's difficult to work out what an obviously wrong report, what the mistake is, what has gone wrong. I call this forensic mathematics, where you're trying to work out what the crime was that was committed to get to that conclusion. Well, looking again through the internet, the 2007 figure for gold production was 7,000 kilograms, or 7.018 tons. So that figure of 7.5 million tons was out by a factor of 1 million. Dimensions often cause trouble. Dimension-wise, the Sportsback, this is a car, will swallow more cubic litres than an A4 sedan, but not as much as an A4 Avant. What do you think a cubic litre is? There's no such thing. Oddly enough, I've heard this often, because I don't think people really understand what that a litre is a volume. In the pre-metric days, nobody would have referred to a cubic gallon. But people refer to cubic litres. And here you have a classic example, even in a motoring column. Related to that, we have this report of one of these car crushing machines. It takes 15 minutes to crush a car into blocks of 1,5 square meters by 1,2 square meters. Now that's a four-dimensional concept. Even if you bring in time, no, you can't. It's 4 dimensions. So this. So what is being said there? Can't really work that one out. An iron, this is a household iron, consumes 1,500 watts an hour, as much energy as 10 100-watt light bulbs. Well, surely the correct figure is 15, at least as 15 100-watt light bulbs. Of course, 15 times 100 is 1,500. Now, the consumption of an iron is indeed 1,500 watts. But to say it consumes 1,500 watts an hour is wrong. The watt is a unit of power. It's the rate at which energy is being consumed by the iron. And in an hour, an iron will consume 1,500 watts, or 1.5 kilowatt hours. You multiply the power of the electricity by the number of hours. So it's not a matter of 1,500 watts per hour. It's 1,500 watts every hour. And so the concept of something going at 1,500 watts per hour is wrong. It's 1,500 watts. It's confusing, really, velocity with distance, or like confusing acceleration with velocity. And you find that in many different places. Here's something reasonably recent, put out by the Nuclear Industry Association. When estimates of new jobs are made, the anti-nuclear lobby bases the calculation on the equivalent megawatts per hour generated. Now, a power station is rated in terms of megawatts. That is the potential power output. So in 1 hour, a 300 megawatt power station will output 300 megawatt hours. It doesn't do this at megawatts per hour. It's not a division by the number of hours, it's a multiplication by the number of hours. Interestingly enough, there is a situation in the power industry where megawatts per hour are relevant. Actually, they don't talk about megawatts per hour, they talk about megawatts per minute. And this is the amount, the rate at which you can bring a dormant power station up to speed. When you switch it on, how long will it take to get to its full capacity of 300 megawatts? And that is measured in megawatts per minute. But megawatts per hour in this context is completely wrong. Now, I was surprised to read this because you'd expect a spokesperson for the nuclear industry to be totally au fait with the distinction between megawatts and power output and energy. It's the power output that is important, not the amount of energy, which depends on whether it's switched on or off. And I think what happened here is that the press release said that it was the equivalent megawatt-hours generated. So megawatts times hours is the energy output. And that is what was being discussed in this context. But I think then what happened is the reporter thought that and saw that and said, oh, that hyphen must be the same as per. So replaced the hyphen by per, replacing the multiplication by division and getting something completely wrong. Now, journalists often have a calculator handy when doing some report, and this is some from a couple of years back, when they handled 6 million pounds of fish every day. Oh, our readers won't understand pounds. Let's do a conversion. So they look up the conversion, they see it's 2.2, so they multiply by 2.2 instead of dividing by 2.2. So again, total misunderstanding by the journalists of what they are writing. Wrong calculator button was pressed. Here's a strange one that I'm trying to get my head around. It concerned a Peter Crouch, who's a lanky footballer from the United Kingdom, of course always in the news, 1.7 centimetre striker. Takes matters to a new low. This is a pun on his height after having been accused of cheating on his fiancée. Well, Crouch's height is certainly a new low. The report was corrected the next day in the paper to 1.7 metres, but even that was not right. His actual height is 1.98 metres. So it's quite fun to see something like that and pick it up and become something worth talking about. When fully commissioned, the Mossel Bay plant will produce 15 millilitres of water per day. Now, any housewife knows that 15 millimetres is 1 tablespoon. So that is a plant that's actually not very functional. It should, of course, have been megalitres, and the little m should have been a capital M. And that means the report was out by a factor of 10 to the 9, namely 1 billion. Here again is another example of confusion of units. When measured in tons per kilometre, about 94% of global trade is diesel powered. Now, when you think about the amount, how stuff is moved around the world, simply in terms of volume or weight or whatever, it's mainly by shipping. And that is diesel powered. So it's not surprising that the vast amount of our global trade is moved around by diesel power. And if you're then thinking about saving on fossil fuels, you've got to answer the question, how are we going to power ship without fossil fuels? The answer is, well, you can have nuclear-powered ships. There are a few. Military, certainly, submarines. The Russians had an icebreaker, which is nuclear-powered. But that is a whole new controversy. The issue here is tons per kilometre. That didn't mean tons per kilometre. To measure the amount of stuff being moved around by different means, you must take tons and multiply it by kilometres. Ton per kilometre doesn't, it's a meaningless concept. It should be ton kilometres or kilometre tons, however you'd like to do that. But this is again an example of a confusion, just like the kilowatts per hour confusion. Here's something where I could have put a pithy headline to. The Cape Town International Convention Centre was tabling 200 horses being sold at this big year sale. The event logistics manager said that between 800 and 900 cubic metres of horse manure were moved out of the stables twice a day, as well as 2,000 cubic metres of straw. Now, 800 cubic metres of horse manure for 200 horses is 4 cubic metres of horse manure being moved out twice a day. What on earth are they thinking about there? Never mind the 2,000 cubic metres of straw. 2,000 cubic metres of straw is just absolutely enormous. So this is really quite a load of horse manure. And again, your forensic maths doesn't give you any clue as to what was going on. By the way, a horse produces about 15 kilograms of manure per day. 15 kilograms, about a bucketful. A nice big bucket. Well, from horses to chickens, it is an astonishing fact that South Africans eat 20 million chickens a week. I checked that. It is certainly true. And this article then goes on to say, or a third of a chicken each day. Now, that means that we here, average South Africans, eat a third of a chicken per day. Well, that's certainly not right, because they did say per week, so we should have divided by taking 60 million as our population. It's a third of a chicken per week, not per day. Then they go on to discuss the waste from South African chickens of 40 million kilograms per year, and I've sat down with a calculator with those numbers and tried to work out what on earth they're going on about. The figure of 20 million chickens a week is really very surprising, and it is accurate. They have to breed chickens up to about 30 to 35 days old before they are slaughtered. So if you are producing 20 million kilograms, 20 million chickens a week, then you'd better have a whole lot of live chickens sort of coming through the system. So there's an awful lot of chickens out there, and they will be producing an awful lot of waste. But 40 million kilograms per year doesn't look right. That sounds like two kilograms per chicken or something in a year. That's certainly not right. The other point is that 20 million chickens per week is not nearly a billion chickens a year. 20 million chickens a week times 52 weeks is over a billion chickens a year. But that's really getting down to quibbling. 160,000 kilograms per day gives 58.4 million kilograms of chicken waste per year, not 40 million. Apart from that initial observation about 20 million chickens a year, which is quite thought-provoking, all the rest of those figures are of no significance whatsoever. Percentages are things that people often get wrong. People's Post. Rondebosch statistics show an increase in 6 of the categories, with robberies of business premises showing the biggest increase at 400%. However, the actual number of business robberies for this year is 4 compared to none last year. Going from none to 4 is an infinite percentage increase, if you like. From 1 to 5 would be a 400% increase. But from none to 4, you can't use a percentage increase because you'd have to divide by 0, which is something that maths doesn't allow, nor does your calculator. And 400% increase of 0, of course, is 0. These percentages, Tony Shapshak was writing in the Times, it went from 0.25 cents to R1.25, as he says, or almost 600%. Well, I looked at that and thought, that's a bit strange. The increase is R1 on 25 cents, so that is not almost 600%, that is exactly 400%. You take the difference and you divide it by the original price. So I thought, oh, well, let me write a little letter to the Times and inquire. Well, I got a response, but they didn't publish my letter, from Tony Shapshak saying he had actually done the calculation and it had come out as 575%, which he had then said was almost 600%, but he thought he'd better check that with a colleague, and a colleague agreed with him that it was 575%. So 2 wrongs therefore make a right. But I still don't understand how either of them could have got 575% out of those 2 figures. Percentages are dodgy, and actually they are very difficult, especially when you get to compound interest. For people to understand the power of compound interest, and this is a serious social problem when people take out a loan and they're told that R1,000 loan, all you do is pay it back at R100 a month over a year. And they can see that they're going to pay R200 more. What's the percentage, what's the interest rate that's being charged by the bank? It's not just 20%. It's more like 150%. Because when you're paying back a loan, you're paying back some of the capital, so your repayment increases during the year. Compound interest is very challenging and people don't understand it. And it's very difficult to guess. You can't guess figures in compound interest because of this exponential factor. Here's something strange from the Sunday Times. The Queen's English used in calling a call centre, 52% of British adults found the Queen's English most appealing. The Scottish accent came back with 34%, and the Northern Geordie twang at third at 20%, and followed by, hang on a moment, we're already over 100%. The least popular accents were those from Liverpool or Birmingham, which tied at 9%. What's happening here? Goodness knows, you can't really guess. How this sort of information is used by call centres in Bangalore or the like, where many of the stuff goes through, I really don't know. But certainly you can understand how people prefer certain accents. Percentages should add up to 100, and if they don't, the whole thing there is pretty suspect. Here's something else. Business report. I forget what was being talked about. It must be a company. Black ownership of the company as a percentage of total ownership is 75.3%. Black female ownership as a percentage of total ownership is 76.5%. How can black female ownership be higher than black ownership unless black male ownership is negative? Because it's the only way those two things can come about. Percentage increases are often wrongly done. Here we have an unsecured lending credit, dramatic 389% increase from a total of 40.9 billion rands to 159.3 billion rands. Now, this is a very common error. The percentage increase is not the ratio of those two numbers, which is what they've done, but the ratio of the difference, the increase to the original number. So it's nowhere near 389%. It's quite a lot more. And oddly enough, a lot of people will think that if something is raised from 100 rands to 300 rands, it's a 300% increase. And yet, if you ask, what's the percentage increase when you raise it from 100 to 200? The percentage increase of raising from 100 to 200 is 100%. It's doubling. So raising from 100 to 300, percentage increase is 200%, not. And these errors are fairly common throughout in our papers. And even then, the calculations can be quite wrong. Here we've got the number of people killed on Western Cape roads. 62 have been killed on Western Cape roads in a certain period, as opposed to 43 over the previous period. That's an increase of 31%. The increase, of course, is 19 out of over 43, and that's the 19 over 43 turns out to be 44%. So how the MSC arrived at that figure of 31%, the increase was percentage increase was far worse. And percentage decreases are quite fun to look out for. Houses were being given away at Woodbridge Island at that time. The price of energy from the wind and solar resources since 2010 has dropped by about 200%. So 200% takes the price into negative territory, so they're going to pay you to use the energy from wind. There's something that often comes up when they're talking about water saving. It's the capacity of dams. And when we've had heavy rain and the dam is overflowing, the report will be that the dam is 104% full. And people will say, well, how can a dam be 104% full? It's either full or not. Well, the fact is that the 104% full is a precise engineering calculation. When a dam is designed and built, they say if the dam wall is this high, it will be full. If we made the dam wall a metre higher, it would have a bigger capacity, but then you've got the cost of the dam and whether that increased capacity maybe causes more flooding further down, back down the river. So the calculation is very carefully done. But the figures are then given for what happens if you've got an overflow of your dam wall of 1 metre. The calculations that the engineers have done when they were designing the dam would say, well, that would have meant the dam would have been 104% of what it is now. So when they say the dam is 104% full, that's what it means precisely, and it's not an error. Although I am reminded of a story that I think is apocryphal about some municipal official, when droughts were being discussed, said, we need to build smaller dams which would take not so long to fill, which is true. Recycling is something that is very much in discussion at present. If everyone in the country collected 1 bottle a month for 1 year, that's 12 bottles per person, times 60 million, that's 720 million bottles, we would have enough power to light up the city the size of Johannesburg. Now, how you convert bottles to power is difficult, and it's also not clear when they say you're going to light up a city. And you collect all these bottles, and even if you convert them, you sell them, or you're saving power and making glass, to light up a city the size of Johannesburg, for how long? Just an hour, or a day, or for a whole year. It's not at all clear from a statement like that what the strength of that recycling exercise really is. Then you have a 400-gram bottle, when recycled, saves 16.8 kilowatts of electricity on the national grid. Well, a couple of quibbles here. It's not kilowatts, should be 16.8 kilowatt hours. Secondly, capital K, little w should be the other way around, little k, capital W for kilowatt hours. And even if that were kilowatt hours, 16 kilowatt hours saving on recycling a 400-gram bottle, that's 16 units of electricity, which say at 2 rands a unit, is 32 rands. You're saving 32 rands on recycling a 400-gram bottle. It's difficult to see what was actually being said here. Maybe the point got shifted back and forth a few places. Goodness knows. Drinking straws have lately been in the news, where it's been pointed out that we should save plastic, or not use plastic, but go back to paper drinking straws, which certainly, in my youth, I remember the paper drinking straws, which you could unravel. It was a helix of a little strip of paper like that, which was neatly turned into a drinking straw, and that was paper. Now we have the plastic ones. And a letter in the Sunday Times the other day said, the average person goes through approximately 38,000 drinking straws in their lifetime. 38,000 drinking straws in their lifetime. Let's take that as a 100-year lifetime. That's 380 drinking straws per day for the whole of your life of 100 years. That's more than 1 drinking straw per day per person on average for everybody. So what is being said here? Big number, totally meaningless. It's certainly wrong. But people are getting very fussed about drinking straws not being plastic. In fact,